Okay, question 2. They've given you some information about metals here. And you had this table with lots of facts in. Why is gold found in the earth as a pure metal? Well, basically, gold is really unreactive. If you think of our reactivity series, it's right at the bottom. Okay, so gold is unreactive, all you need to say for 1 mark. Aluminium, you are told, is the most common metal in the Earth's crust. Suggests why iron was able to be extracted much earlier than aluminium. If we look back to our table, aluminium wasn't extracted until 1825, whereas the iron was about 3,000 years BC, the Iron Age. So, the key point here is that aluminium is much higher in the reactivity series than iron, and that's going to affect how it is extracted. Aluminium has to be extracted using electrolysis, and we didn't really have electricity and the technology until around that date. It was discovered in 1825. Whereas iron can be extracted using carbon and a reduction reaction. So, hopefully that rings some bells. Right, determine the ratio of the annual production of aluminium to iron. So you've got to use the data from the table, and you're going to be using the iron aluminium numbers here. So you should get 1.15 times 10 to the 12, got the bigger number at the top, divided by 7.76 times 10 to the 10, gives you 20. So you've got a 1 to 20 ratio. Some of you might have got 19.96. That's fine. Suggest 2 reasons for the difference in the annual production of aluminium and iron. Well, it costs more to extract iron. We've got to use electricity, so that's going to increase costs. The other one you could say is that it also requires more energy to extract aluminium. Oh, I think I said that one twice, haven't I? It's harder generally to extract it as a method. There is less demand for aluminium. Iron we use in lots of products. If you think about all the uses of steel, which is an alloy of iron, there can be more uses of it. So yeah, use energy, costs more because it uses more energy. Right, you had to balance the equation. So I'm going to go through this one again actually. So you are told that you've got Fe2O3, you've got carbon, and you've got iron being formed and carbon dioxide. So when you're approaching these, you need to first identify what have you got. So on this side we have got 2 irons, 3 oxygens, 1, 2, 3, and 1 carbon. On this side we have got 1 iron, 2 oxygens, and we've got 1 carbon. Now I've laid these out in the same order on both sides just to save me getting muddled. So the iron is going to be pretty easy to fix. There's some iron by itself and there's some carbon by itself, so they're going to be easy to fix. So I'm going to pick to balance the oxygens first. So I've got 3 on one side and 2 on the other. So I'm going to be looking for the lowest common denominators, in this case 6. So I'm going to put a 3 here to get 6 oxygens, because 2 times 3 is 6, but that also increases my number of carbons to 3. Iron's not affected. I want to get the 6 oxygens on this side, so I'm going to put a 2 here, 2 times 3 is 6, but I've also increased my iron to 4, carbon's not being affected. So my oxygens are happy, so I need to sort out these carbons and iron. So if I fix the carbon on this side, just by putting a 3 there, my carbons are now happy, and I need to get 4 of the iron on this side, and it is now a happy balanced equation. I know they don't always give you room to do this, but you'll find a bit of room in the margins. Pace yourself and be a bit ploddy with it. No problem whatsoever. Right, what type of reaction produces iron from iron oxide? This is a reduction reaction. So reduction is gain of electrons or loss of oxygen. Right, we've got one more bit of question 2 to go. This one we didn't do so well answering as a whole. So iron from the blast furnace is called cast iron. Cast iron contains approximately 4% carbon. Cast iron is harder than pure iron, and they show you a diagram. Explain why cast iron is harder than pure iron. So look at the differences in the structures. Pure iron is in layers. Look how that regular arrangement of the atoms. And because of that, they are able to slide over each other. This side, with the larger molecules added to it, we've disrupted that regular structure, we've disrupted those layers, or we say they've been distorted, so they can no longer slide. So even if a few people left this on blank, you weren't sure about what an alloy was, you'd forgotten that definition, you could have done spot the difference. So it's always worth trying these questions. So pure iron's layers can slide over each other. In cast iron, the different side atoms distort the layers so they can no longer slide. And that's question 2.